only able to construct Bayesian models on 3 Viejo period sites from their project. For the Bayesian modeling, the criteria to do the modeling on a particular site was based on a site needed to have at least 4 radiocarbon dates from context directly associated with the occupation period, either Viejo or Medio, in question. And unfortunately, most of their radiocarbon dates came from unsecure context, such as arroyo cuts, post-occupational fill, test pits not associated with architecture. Therefore, the majority of their sites could not be modeled. But was able to use Calderon, Quevedo, and CH240 from their projects. None of their Medio sites met the criteria for chronological modeling. I was able to use projects from Mike Whalen and Paul Menace and model sites 204, 231, 242, and 317 to use to compare with the new dates from Paquimé. So in total, I have 133 dates from 12 sites in the Casas Grandes area. So for the general model construction, all the dates used in the models were conventional radiocarbon ages that had been corrected for fractionation. All the models were constructed in OxCal 4.4 with the NCal 2020 calibration curve set at a resolution of 1 year. The models were run with 20 million Markov chain Monte Carlo iterations to ensure stable outcomes. And unless otherwise noted, particularly with Paquimé and Convento, all the models that will be shown for the other sites includes a general outlier analysis in which all dates are given a prior probability of 5% of being a statistical outlier. And all models that will be shown in this presentation have a good overall model agreement, that is a model agreement index of 60 or greater, indicating that a good fit between the data and the model construction. And all the results here are shown with the endpoints rounded to 5 years. So I will briefly go through the model construction for the 12 different sites and save the results, even though they're shown on the slide, when I get to the comparison slide, given time constraints. So looking at the Viejo period sites first, looking at Quevedo, we have 7 radiocarbon dates on short-lived specimens from 2 pit house structures, and 3 test units. The structure units were modeled as a single continuous phase of activity. Like I said, I will go over the results when we get to the comparative slide. Calderon, we have 29 radiocarbon dates on short-lived specimens from 6 pit house structures and 2 test units. The model was constructed as a single continuous phase of activity. However, it incorporates the stratigraphic superposition of structure 4 being constructed over structure 2. And then we have CH240. We have 12 radiocarbon dates, again, all on short-lived specimens from 3 structures, 2 pit houses, and 1 possible Hakal structure, and from Midden. The site was modeled as a single continuous phase of activity, incorporating the stratigraphic superposition that structures 2 and 3 were partially constructed over structure 1. We do have 1 date on grass that was found on the surface that was much too young for the context, and given the fact that it was from the surface, we do not actually know the association of the date to the site, and so that date was marked as an outlier and omitted from the model. And finally, Convento, which I'll go into a little bit more detail here. These are new dates from the work submitted by Meredith Snow and Michael Searcy. We have 8 AMS dates on articulated individuals from sealed mortuary pits from below the floor of the plaza area, which DePeso described as type 3A. These are all from DePeso's excavation. Or sealed mortuary pits dug into abandoned structures, type what DePeso referred to as type 7A. The site was modeled as a single continuous phase of activity. We did have one individual 16, was an adult female, fully articulated in an intrusive pit found in the floor of House I. Now, this individual had a radiocarbon date, or calibrated radiocarbon date of 760 to 410 BC. Given that this was an articulated individual into a pit house with ceramics, a essentially archaic date is obviously erroneous. And this date is likely due to either poor collagen yields and or issues with pretreatment. This individual was excluded from all models. I constructed 2 separate models for Convento. The first just includes all the dates in a single continuous phase, and the second includes the general outlier analysis, which gives each date a prior probability of 5% of being a statistical outlier. With the Model 2, the outlier analysis flagged individual 55, which was an indeterminate juvenile buried in the plaza, as having a 15% probability that this was an outlier. And we will see that with the general outlier analysis, that individual is downweighted, roughly 15% in the model. And we'll see that this one particular individual downweighting its results has a significant impact on our results. Then for our Viejo period, to look at the overall Viejo period chronology based on these 4 sites, took the posterior density estimates for the start and end of occupation from each model and modeled it as a single continuous phase of activity. By taking using the posterior density estimates from the individual models and modeling them as a group allows for sites with more dates to be weighed the same as sites with few dates. Model 1 includes the Convento Model 1 results, in which we just have a single continuous phase of activity. The Viejo Model 2 includes Convento Model 2, which also includes that general outlier analysis. Although Model 2 had an overall acceptable agreement, it did flag the ending date for the Model 2, Convento Model 2 date as being having a low individual agreement. So the results, kind of looking at a better way to look at the results of the models for the Viejo period. A schematic diagram here shows the period of use in a given 25-year period for each site, as well as the overall Viejo period from the models constructed. So the period of use uses basically or calculating the probability that the site was in use given any 25-year increments from AD 800 to 1350. The horizontal bars shown here represent the probability that the site or the period was in use in that 25-year period. The darker the shading, the higher the probability that the site was in use. And here we can see really the major impact that individual 55 has on Convento. Model 1 shows that Convento, the highest probability was in use from AD 975 to 1250. However, just downsampling or downweighing individual 55, roughly 15% in the model, reduces our occupation estimate from 1,000 to 1075. Comparing Convento to the other Viejo period sites, with the exception of CH40 having the possible Jacal structure, are all pit houses where Convento does have Pueblo. We would expect that Convento would have a longer occupation period. Therefore, the Model 2 is likely not possible, although, again, we don't have enough information to definitely exclude it. And we can see, based on these sites, the Viejo period is estimated in Model 1 at 975 to 1250, and in Model 2, 975 to 1125. Again, Model 1 is probably more likely than Model 2. For the Medio period sites, focus mostly on the work by Mike Whalen and Paul Minnis. All of their sites, these were dated primarily in the 2000s, did use a lot of wood charcoal was dated. However, most of their wood charcoal came from fire pits and hearths and was not architectural wood. Also, they were able to date some corn cobs, so short-lived specimens. A series of chi-squares, Ward and Wilson comparisons for the wood and corn dates found that in most cases, the wood and corn were statistically of the same age. Therefore, using something like charcoal outlier analysis did not seem warranted, although a general outlier analysis was used on all these models. In cases where it was determined that the wood charcoal was in fact old wood, it was included in the model as a terminus post quem. So site 204, Whalen and Minnis divided into distinct, like 6 distinct areas for which met the criteria for constructing the Bayesian models. So for Mound A, Area 1, we had 13 radiocarbon dates on wood or wood charcoal from 9 Pueblo rooms and 1 intrusive oven. The model was constructed as a single continuous phase of activity and incorporated the stratigraphic superposition of a subfloor fire pit and floor in room 8, and that the oven feature 60 occurred after the occupation of room 51. The unburned wood post, again, one of the few cases where they were dating architectural wood, was deemed too old for the context and was likely old wood and was included as terminus post quem. We also had 1 date from room 6 based on, we had 2 dates from the site, that this was too young for its context, likely residual, and was marked as an outlier. Site 204, Mound A, Area 2, we have 5 radiocarbon dates on wood charcoal and 1 date on charred corn cobs from 3 Pueblo room fire pits and plaza floor. It was modeled as a single continuous phase of activity and incorporated the stratigraphic superposition of subfloor and floor context from the two rooms. 204 Mound A, Area 3, 7 radiocarbon dates on wood charcoal, modeled as a single continuous phase of activity, with 1 date from room 32 included as terminus post-quem. Finally, the last area in Site 204, Mound C, 4 radiocarbon dates on wood charcoal from 2 Pueblo rooms, modeled as a single continuous phase of activity. Site 231, 9 dates on wood charcoal, 1 date on corn cobs from 3 Pueblo rooms, again modeled as a single continuous phase of activity. Site 242, 12 radiocarbon dates on wood charcoal from 5 Pueblo rooms. 2 of the dates, 1 from room 5 and 1 from room 8, were considered old wood and included as terminus post-quem, and the site was modeled as a single continuous phase of activity. And Site 317. Site 317 was a bit more complicated. We had 4 radiocarbon dates on wood charcoal from 3 Pueblo rooms, 3 dates on charred corn cobs from 2 Pueblo rooms, 2 dates, 1 on wood charcoal, 1 on corn cobs from an oven found underneath the Pueblo rooms, and 2 dates on wood charcoal from a pit house from underneath the oven. So we have considerable stratigraphy found at this site. However, the pit house, dates from the pit house seem to be quite problematic in that both were too young, considerably younger than the oven, which also included our corn cobs. So the pit house dates were marked as outliers and excluded from the model. So the model, the site was modeled as a sequential phase of activity with the oven preceding the Pueblo rooms. And the results from the model, which I'll discuss shortly, will focus just on the Pueblo rooms. And then we have our new dates from Paquimé. We have 16 AMS dates on individuals from deliberate mortuary features or unburied type 2, what DePeso referred to as type 2, individuals from floor surfaces or roof fall debris. 3 different models were constructed for these dates. The first includes all dates as a single phase of continuous activity. However, 1 date, individual 3311 from Unit 11, has a low agreement, although the overall model is in agreement, so it is left in the model. Model 2 is the exact same construction as Model 1, but includes the general outlier analysis. And with the general outlier analysis, it deems individual 3311 that is having 100% probability that this is an outlier, which essentially excludes it from the model. And you'll see that this has a major impact on our results for our modeling. Model 3 incorporates sort of DePeso's idea that that the deliberate mortuary features would have occurred prior to the type 2 mortuary features in a continuous phase of activity. And here again, individual 3311 and individual 1811 have low agreements, although the overall model is in good agreement. Now, one of the other main problems that we have with trying to construct chronologies for Paquimé is that all of these dates fall on either major wiggles or plateaus on the calibration curve, as shown here in a little diagram calibration curve below, where you can see circled that the dates are hitting these major wiggles, which results in very strongly bimodal or multimodal and extended distribution of date ranges, which sort of hampers our understanding of the chronology. And unfortunately, at this point, the Bayesian analysis is not able to overcome some of the issues with the calibration curve. We'll go more into the results in the next slide, but kind of showing one of the difference with Model 3, we are able to look at a possible transition, looking at DePeso's sort of end of for the destruction of Paquimé, sort of looking at the transition between deliberate mortuary features and type 2 mortuary features likely occurred around AD 1310 to 1385 at a 95% probability. The dates. Oops. And then using the dates from Whalen and Menace as well as Paquimé, also like Convento, looking at the using these dates to construct an overall medio chronology. 3 different models, again, incorporating the 3 different models from Paquimé. The first being the simple phase model, the second including the outlier analysis, and the third is the sequential model with deliberate mortuary features occurring prior to type 2. Again, the period of use, calculating the highest probability within the 25-year period between 1025 and 1550, allows for a better comparison of these site models. One, if we look at Paquimé, we can see that that one individual, 3311, when that is excluded from the model, we have a major impact on the model. Model 1 estimates the highest estimate probability that Paquimé was in use is from 1250 to 1325. Model 2 with the general outlier analysis where individual 3311 is omitted estimates the occupation at being 1300 to 1325. And the model, which includes deliberate mortuary features over type 2, suggests that Paquimé was probability of the highest probability when it was occupied was 1225 to 1375. Comparatively, we see that these do fall within the date ranges of the sites from Whalen and Menace. And when we look at the overall medio chronology, again, we have some differences with the how Paquimé interpretation of Paquimé, but the medio period lasting either from 1250 to 1425 from Model 1, 1250 to 1400 in Model 2, and in Model 3, 1225 to 1425. Now, one of the issues in dating human bone is that it can often be, the dates can often be misleadingly old due to the consumption of fish or other resources from aquatic, that being marine or freshwater, food chains, as these are not in full isotopic equilibrium with the atmosphere. Now we know Paquimé and Convento are located near the headwaters of the permanent flowing Casas Grandes River. In addition, millions of species of shell have been recovered from Paquimé. So we need to see whether or not there is sort of a dietary radiocarbon reservoir offset on these individuals. Now, unfortunately, the dates that were run for Convento and Paquimé, stable isotope analysis and carbon-nitrogen carbon-nitrogen ratios were not conducted, so we have minimal information on these. However, recent research by McConnon-Borstat suggests that there was a minimal marine diet, given that the diet mostly seems to be a C4 CAMS terrestrial terrestrial resources. However, even a small dietary reservoir offset can have a major impact on radiocarbon dates. So given that we is still mostly CAMS or C4 CAMS diet, to look at what potential a dietary reservoir offset may have, what impact they may have on these dates. A series of simulation models were run using Paquimé Model 1 and Convento Model 1, in which each individual, we looked at a minor dietary reservoir offset, moderate, and major. Minor offset, each individual was given a randomized DRE correction of between 0 and 40 radiocarbon years, meaning 0 meaning an individual had no dietary reservoir offset, up to 40 radiocarbon years with an uncertainty of 10. A moderate effect, looking at each individual was given a randomized DRE correction between 0 and 100 radiocarbon years with an uncertainty of 10, and a major DRE effect, looking at a randomized DRE correction to each individual of 0 to 200 with an uncertainty of 10. And again, look using the period of use schematic diagrams to look at the potential impact. On the Convento dates, we can see that the minor, just having a minor, some individuals having a minor DRE reservoir offset can impact our understanding of the chronology. From the original model of estimated period of use of 975 to 1250, with just a minor DRE effect, our estimated period of use is 1,000 to 1275, so pushing about like 25 years. It is unlikely, given the other material cultures, that a major DRE pushes it much further back in time, seems unlikely. With Paquimé, again, we see that even a minor, some individuals having a minor DRE offset can again impact our chronology. And in fact, and with this particular run of the model, all three, moderate and major, although given previous stable isotope works, a major DRE offset is unlikely, fall within the range of our estimated mediochronologies. So more work needs to be done. So although we've looking at all these different sites, we still have more questions than answers. So directions for future research to help resolve some of these questions. One, we know we have with Convento, we have one erroneous date that is either due to low collagen yields or pretreatment issues. So we need to assess and validate the existing dates by running replicate samples at different labs, different radiocarbon labs. And this is something that is in the works. It is also essential anytime that bone, whether it be human or faunal remains, are dated, that we need to get the stable isotopes, delta 13C and delta 15 nitrogen. as well as your carbon-nitrogen ratios, because these can also help determine whether there are issues with the radiocarbon dates. So these are essential, should not be seen as optional. We need to identify and date perfect pairs. That is, get radiocarbon dates on contemporary terrestrial and freshwater faunal remains from Paquimé and Convento. Convento is limited given the only a few faunal remains were recovered. However, this is something that could be done at Paquimé. And finally, to help really overcome especially the problems with the calibration curve, we need to focus on stratigraphy. Incorporating stratigraphy into the models helps eliminate some of those multimodal and long distributions and to get samples from stratigraphic context. Another area of potential use to refine our models is to look at wiggle matching. We know that the cutting dates from Paquimé have been significantly shaped and likely also some due to preservation loss, that these are much earlier, and actually I tried them in the model. They're so early they have no impact on our radiocarbon dates. However, wiggle matching may allow for more precise estimates of cutting dates that would make these dates more useful in the models to give us better understanding of the chronology. So like I said, we still have more questions than answers, although incorporating a Bayesian framework to look at the chronology of Casas Grande areas is likely a fruitful direction to follow. Thank you.
Thank you very much, Doctor. Elías, ¿alguna pregunta parte de ustedes?
No, Oscar, no tenemos ninguna pregunta.
Correcto. Gracias. Okay, Doctor, we would like to appreciate your time, your knowledge, and thank you very much for this conference. We appreciate it.
Thank you for the invitation.
Thank you very much.
Okay. Bye.
Goodbye.